Ah, hello everyone. Welcome to Adult. Physics is very easy when you learn with a great teachers. No, I'm just kidding. No, there are few topics in physics which are not connected to your other topics. Let's say it is connected just like 1%. Without that also you can learn this topic. That kind of topic is your modern physics. In that modern physics, we start with our basic topic like dual nature of matter and radiation. After that, we will study atoms. After that, we will study nuclei. But basically, this is basic. If you know this, that can easily you can do. But basically, you must study atom first. After that, this it's okay now. Whichever you study, we will study. Relax, chill. Take your notebook, start writing, and let us start. Myself, Tofik, and welcome to Added, the place where we add knowledge to your brain. So let's get started. So basically, this chapter today in this section we are going to discuss few things. We are going to discuss few things just like this one, electric discharge through glass at low temperature. Low temperature, whatever the phenomena is happening, we are going to discuss today. There are five phenomena happening. In that, only three or two is very basic and very necessary for you. We will discuss that one. After that, cathode ray tube, which is very important as far as NEET syllabus. Even this also important, but in this only two topics are very important. But in this full is very important. After this determination of E by F ratio, this is one of the greatest topic and one of the interesting topic. And J.J. Thomson, your grandfather J.J. Thomson, find the electron. You will study him. Will be some respect. After the Millikan drop experiment, the charge of electron finding. After that, electrons emission and types and previous year question. Be present until the last, because last we have some beautiful and very simple questions of previous year NEET. So if you be up to last, you will learn something. Okay, let's get started. Let's get started. Now, before that, before learning anything, we must know why we are learning this topic. Why we are learning this topic? Why? Why? Why this chapter is given to you? You know, in previous year till now, many fights are going on. Nature of it. Because of nature of it, some say light travel in the form of waves, some say light travel in the form of particles. No, huge confusion, no? Huge confusion. To solve this confusion, we say light travel in the both forms. It depends. It depends, we say. That we are learning in this chapter. So see, in early 80s, there are few scientists. See, there are few scientists. Maxwell, Maxwell, not cricketer Maxwell. It's a scientist Maxwell. Okay, Maxwell and Hertz experiment. Hertz is a just scientist. His experiment name is Hertz experiment. Maxwell and Hertz now together they perform electromagnetic experiments, and with the help of generation of deflected electromagnetic wave at the age early 80s they use electromagnetic waves and show that light travel in the form of waves. These two fellows shows that light travel in the form of waves. But we are science students. We'll never stop. We'll never stop. Okay, man, you should. I Maxwell, you should. Okay, according to you, light travel in the form of wave. But I don't believe. I don't believe. I don't agree with you. This comes at the same time. The time when this both explain that light travel in the form of wave. At the same time, few scientists explained that few scientists got some beautiful results by explaining that light travel in the form of nature, particle, right? Travel in the form of particle, nature. Someone asking, sir, is it for CBSE? Yes, it is for CBSE and it is for NEET and including it is for IIT. Basically, it is more focused on NEET. You can prefer it for IIT also. Okay, let us continue. Now, before I said now three scientists, not three dates, movie, three scientists. This together changed entire right nature. First, your William Crookes. It's not wearing Crocs. It's not slipper Crocs. It's Crookes. William Crookes. He uses electric discharge tube, and produce, or you can say develop cathode ray. He uses electric discharge tube and produce cathode ray. You can say he has father. After that, Same time, this phenomena used by Thomson, J.J. Thomson, who find the electron. Father, he is his father. His son is J.J. Thomson. Not, Arey Baba, really not father and son. I'm just telling. Don't mistake their father and son. I'm just telling in a funny way. This method, the cathode ray is father. Okay, now this is fine. Cathode ray is father. Now using cathode ray father, this J.J. Thomson find 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 this ratio. Where it gone? Where it gone? Where it gone? My line. Okay. Find this ratio. E by m ratio. You can say E by m ratio or electrons. He find electrons. Basically he find electrons. Okay, I will change, wait, I will change color. Okay, basically he find electrons, and this E by m ratio, which is very important ratio, and you must keep this in mind. What do you mean E by m ratio? Charge by mass ratio. E is equals to what? E is equals to what? Very simple. E means charge, M means what? M means mass. That's simple. Charge by mass ratio, very important thing, remember. And after that, using this fellow, this A.R. Rahman, sorry, not A.R. Rahman, this R.K. Millikan, we call it Millikan, producers are derived the charge of electron. Charge of electron nowadays you can say 1.6 10 of minus 19, but at that time it's a huge discovery. So this RA Millikan music director develop the charge of electron. Charge of electron. Basically, I want to say you that first there was a wave particle who are discovered, wave nature were discovered by William Williamson, Williamson and some Williamson. No? Maxwell, sorry. See, I am also in the mood of cricket. Williamson, I am telling you. Maxwell and Hertz experiment. After that, these three scientists come. They will say that no, this is travel in the form of particle. They will explain line balance. We will learn. Before that, this there now. What we are going to learn, we are seeing. Okay, Milton Crookes will come. He said cathode ray. He used cathode ray to develop some cathode rays. And after J. Thomson comes, J. Thomson says E by M ratios. After that, you are very A.R. Rahman, R.A. Millikan comes. He says the charge of electron. Basically, in this class, we'll study all this. Okay. Now your first. Oh, what? Am I looking good? No, camera quality is not good. Okay, it's okay. Next time we'll improve. Okay. Now, first comes your William Crookes. William Crookes, and what is it? Electric discharge tube. Now, before that, let us know what do you mean by electric discharge tube. Electric discharge tube, like it's just a tube, is just electric tube which is filled with gas, which is filled with gas molecules, and one side it is basically one side negative, negative, which means cathode, and one side positive, which means anode. Positive side we call as anode, and negative side we call as cathode. Now there is energy passing. Energy passing. Let's say this positive, negative. Now positive, negative. Oh, one second. Oh, sir, Tofik sir, what you are doing, sir? This is wrong, sir. This is wrong, sir. This is wrong. Oh, yeah. Everything gone now. Two. It's okay. I will draw once again. Everything gone. Okay. Small mistake, gone everything. So this is discharge tube filled with gas molecule. Remember gas molecule, which is very important. Gas molecule. And one side it has negative charge, which act as cathode, and one side it has positive charge, which act as, and you all know this one, this is basic, you all know. And this is okay for you. I will write why, when we are learning first time, we have to learn very deep. Cathode, and one side anode. Now basically this here become positive, this becomes negative. This is a mistake which I made last time. Now I'm not repeating. Never repeat your mistakes so that you become success. Okay, now, okay. And this is simply your vacuum creating pump. Vacuum vacuum creating tube, or you can say vacuum. When you rotate, you can create vacuum. That's all. Okay. Now now, if you feel gas molecule, if you feel gas, what happens? All over, gas molecule generate. All over, gas molecule generate. All over, gas molecule generate. And one more thing, in this discharge tube. Now, whenever we are talking about discharge tube, we always say low pressure, low pressure. Whenever we are talking about whenever we are talking about discharge tube, we will always say low pressure, low pressure, low pressure, low pressure. But low pressure, but high voltage. Why high voltage? Means to generate electric field. Okay, now when I pass this both, what happens? First thing happens is electric field travel from this side to this side, right? You know, electric field are travel from positive to negative. Electric field in first chapter electricity you are studied basic unit electricity. Electric field lines are coming outside the positive, going to negative, reaching negative, and making product babies. Array, what babies? No, reaching it and ending, or else it will end in the infinity, right? But when electric field passes from positive to negative, charge, electron passes from negative to positive. Why? Electron is negative charge, so it will attract by positive. So both are opposite. Both are opposite. Don't get confused. Okay. Now basically, low pressure, high voltage. This is the main focus. Keep focus. Now let us see next what happened. See, okay, clear up. See, clear. Electric discharge tube at low pressure and discharge. Array, electric discharge through a gas at low pressure in a discharge tube. Okay, same. Okay, now let us discuss. Now, first, normally everyone say first experiment, then result. But we are different. We are different. First, we study result. Then we study why this happened. Okay, now simple case. First, uh, first we must study why we are eating. After that, we will study what we are eating. Sir, you are super, sir. Now, first pressure, we said now low pressure. Low pressure. Now, let's say low pressure. First, low pressure is 10 mm of Hg. Micro. 10 mm of Hg. At this time, what happens? Let us see. At this time, what happens? Let us see. Okay, I will write this for you. This I will write this side also. This. Okay. Adjust, man. Adjust. It's okay. Adjust. Parvale. Arrow options are okay. No need. Okay now. Okay, fine. Now see. At this time, when I apply 10 mm Hg pressure, which means how much it is low only. 10 rupees is low only. Nah, you are giving bigger 10 rupees. Then here also 10 low, which means see, it is basically it is not m. See, it comes like this, 10 to the power of minus 10. No, now basically it happens 0.001. Low pressure. At this time, what happens? Let's see. A luminous bright column is observed in between positive and negative. This column is known as positive column. This column is known as positive column. The color of positive column, it depends on nature of gas. This is important. This point is important. This is very simple, Ram. See, when you put 10 mm Hg of pressure now, low pressure, at this time, positive, negative, in the between positive, negative, there creates a new bright area. See, here creates a bright area. Are you able to see this area? Are you able to see this area? Literally, this bright area. It is bright area. This bright area we called as positive column. This bright area we called as positive column. This happens when you create 10 mm of Hg pressure, low pressure, low pressure. That's it. And this is depend on this brightness. But maybe brightness is less, brightness is more. This is depend on the nature of gas molecule. Nature of gas molecule, important point. Note down nature of gas molecules. Now, okay, 10, okay, nothing extra in 10 is just simple thing. Now we'll reduce more, we'll go deeper. What if I keep 3 mm Hg of pressure, low pressure? 10 is low. In that I am keeping 3, very low. Let's see what happens. Now, when we decrease the pressure, then the positive column, see here, mark it, positive column decreases in the length and a glow can seen around the cathode, and there is a dark place between the glow and the positive column. Simple thing. The glow around the cathode is called as cathode glow or negative glow. The dark space between is called as Faraday dark space. Very simple. Huh? When you reduce 10 mmHg power to less power, that time now this positive column is there. Now positive column, see in this area, positive column is there. Now positive column. This positive column decreases. This positive, see here compared to this one, compared to, see I will draw one line. This is like this. Now compared to this one, this area is reduced. This area is reduced. Your positive column reduce, and here if you see here a new creation you can see. Here new thing is created. This new thing at the negative, this new thing at the negative, we call it as cathode glow. It is cathode, so cathode glow, or else we can even say it as negative glow. This is called as, I will write down, it is called as cathode glow. Cathode glow. And this distance is there. Now this distance is basically dark. Now to show you, I written like this, it is basically dark. The distance that's placed between this and this, it's dark, and this we call as Faraday dark space. Faraday dark space. Faraday dark space. See, very simple. When you reduce pressure from 10 to 3 mmHg, that time this positive column is it reduces, positive column reduces, and as it reduces, there is a small glow can see at negative. That glow is called as cathode glow or else negative glow, and this glow and this column has certain area between them. You can say dark area. That dark area is called as Faraday dark place. Simple, clear, okay, mind it, okay, clear. Now let us see one more slide. Clear. Now third slide. From 3 mm of Hg to 1 mm of Hg. 1 mm of Hg. Very simple, very simple. See, on further decrease the temperature, on further decreasing the temperature of positive column, on further decrease the temperature, then sorry, this is then, okay, it's my mistake. It is then the positive column is further shortened. See here, positive column, which means starting a column, developing a bright column, positive column, it is further decreased, shortened, and the length of Faraday duct place increases. Length of Faraday duct place increases. Faraday duct place is what? Faraday duct place. This area is there now. This area is known as Faraday duct place, which is increased. The cathode glow detaches from the cathode. See, cathode glow discharges from the cathode, and a new dark space develops, is a crop dark space. Crop or dark space. Now see, basically this what is telling now. It has positive column. It is positive column, positive column. Now see from initial positive column. In the first figure, positive column is very huge. In the second figure, it is started decreasing. Now in the third figure, it is started more decreasing. Okay. In the third figure, it is started more decreasing. And when you put 1 mm HG pressure now, at that time your cathode glow is there now, that detached from cathode and move little further. Cathode glow, okay, I will write for you. Cathode glow detached from the cathode and move little further, and here create some dark area, which we call as Crocker dark space, which we call as Crocker dark space. Super. Now this is normal, you all know. This is normal, which is called as Faraday dark space, which is called as Faraday dark space. Clear? All this happening at 3 mm of HT power. Now let us discuss little more, because one is okay, but 0.011, it's very okay. Okay. Now 0.1 mmHg, huge, 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 very very low. And this case is basically important for NEET. NEET purpose is very important. Okay, let us see. On further, same again the same thing. Further decrease in the 0.01 mm of Hg power. What happens is Crocker dot space, and cathode glow expand. The positive column is split into alternative dark fringes, dark and bright fringes, which is called as striation. Very simple. When you decrease 0.1 mmHg of pressure, that time there is one small place is there in between cathode. Wait, I will write here, or else you will write same in your notes also. There is a place between negative and this cathode glow is there, which is called as crocodile place, that expand crocodile dark place, crocodile place. This is dark place, this is dark place. It is not dark web, it is dark place. It is not dark web, it is dark place. Your what is it here, what is it your crocker dark space, crocodile space expand. And this your strangest, see basically here your positive column is like this. Now this positive column is break down into small fringes. That fringes we call it as striations, or you can say fringes. Oh sorry, fringes, or you can say fringes of positive column fringes. And this area normal. Do I need to write? Okay, I will write. This area is your Faraday dark space. This area is your Crocker dark space. Okay, not a nice handwriting. Adjust information is well. Information is well, not a handwriting. Okay. Now at 0.1 mm very simple thing. Crocker dark space increases, and this positive column break down into stringes. Simple. Remember this because this is important. Now next case, final case. If that is important, then this is very 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 very, very important. Yeah, very 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 important. You must remember this. Okay. Now 0.01 mmHg of pressure, very 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 low pressure, low low pressure. Further on decreasing the pressure to 0.01 mmHg, the striation vanishes. Shit. From striation, see, striation was like this. You decrease, it become like this. You decrease, become like this. Decrease, become like this. Decrease, breakdown. Now finally vanish. Gone, gone. Finally vanishes. See, striations vanishes. Cathode glow also vanishes. Cathode glow also vanishes. Okay. The Cropper dot space will enter into. See, this is important. Cropper dot space will enter into a new phenomena starts at this place. Okay, the walls of tube begin to glow. Tube walls. Walls of tube begins to glow, and this is we call as fluorescence. This we call as fluorescence. The color of glow depend on the nature. The color of glow depend on the nature. Eh? Two times. Oh, sorry, man. I have written two times. Okay, parallelist. The color of the wood depend on the nature of glass. See, this is important. Depend on the nature of glass, and it is yellowish green for soda glass. It is yellowish green for soda glass. Basically, what they are telling. What they are telling. See, you write theory. I explain what is inside. Okay. You write theory. Now, basically, we know this is our cathode and this is our anode. We know. We know. Now pressure is low, very 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 decrease. Pressure is huge decrease. Pressure is huge decrease. There is nothing pressure in your brain. Nothing pressure in your brain. Now nothing is there. At this time what happens now? There was like this cathode glow, and there was some singes like this striation, right? Striation. Now I decrease pressure to 0.001 mm of Hg. That time what happens now? These, these, this fellow, these striations vanishes, and this also get vanishes, and all over there are some dark space now. There are some dark space. See, this dark space is there now. This dark space fill the entire tube. This dark space fill the entire tube, and this surface. Okay, I will take a bright future like you. uh, Not a bright. Which one is bright? Which one is bright? Okay. Yellow only bright. Okay. This started glowing. Oh, ho, ho. La la la. Alale. La 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 la. La 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 la. Okay, adjust. There is nothing wrong in adjusting with your girl or boy. You will adjust now. Adjust here also a little bit. Okay. Now this area becomes bright. Why? Why? Why it becoming bright? Why? 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 Ask this question here. If you don't get answer, I will tell you answer. Why it is becoming bright? See, at 0.01 seconds, very simple. All striations are vanished, all cathode rays are vanished. Only remain is crocodile dark space all over the tube, and we can see that the tube borders are bright, especially anode side. Anode side. Remember, especially anode. This point is important. Anode side is bright, and this process we called as formation of light means luminous now. Light means luminous, or you can say fluorescence. This process is called as fluorescence. See, there is one small symbol here added, which is very beautiful. Just go to my channel and subscribe it. Promotion of, okay, now promotion. Okay. Now after that there are few points. Let us see each point. After that we'll discuss why why wait, idiots. Once again, cathode ray. Okay. 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 Why this happening? Why this happening? You're beautiful, but why? 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 Okay, take down this. I will write in this only. I will write in this only because there is no place. There is no place in my heart for you. Okay. Now, basically, there are few things. There are few things happening at low pressure. There are few things happening at low pressure. Low pressure. One thing, when you exert low pressure, vacuum. It's create vacuum. When you exert low pressure, basically in the whole tube, it becomes vacuum. It becomes vacuum. Vacuum means there is no there is no 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 no. Okay, we forgot one thing. Come here. Okay. Now see, basically why this happening, I will tell you why this happening. I will tell you. Okay, once, can I run this? I will run this. Okay, I think you noted down. If you are not noted down, go again, go past, note it, because it's very important. Now see, basically why this dark and bright forming now? Why this dark and bright forming? I will tell you. I will tell you fine. See, you know one thing. When we pass in the cathode tube, it is some gas molecules is there. Gas molecules. See, basically gas molecules is there. Basically, gas molecules is there inside the cathode ray. Now, when I pass some electric field, when I pass some electric field, When I pass some electric field, what happens? This cathode ray, this cathode ray, this cathode ray consists of positive and negative both. When they pass electric field, this inside this cathode ray, gas molecule, inside this gas molecule, negative wants to move towards positive. Okay, now negative wants to move towards positive. Negative wants to move towards positive. Negative wants to move towards positive. La 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 la. Negative wants to move towards positive. If negative coming out of the gas molecule, then what remains? The only thing remains is positive. Only thing remains is positive. Only thing remains is positive. Now positive attracted by negative. Here, see, positive moves this direction, goes very fast and strike the cathode, goes very fast and strike the cathode, goes very fast and strike the cathode. When you're striking the cathode, and make that cathode to emit electrons, and striking the cathode, make this cathode to emit electrons, make this cathode to emit electrons. Basically, one thing, inside the gas tube, inside the discharge tube, there are gas molecules. When they apply some electric field, that gas molecules, which consists of positive, negative ion, negative electrons moves towards anode, and positive remaining molecules go very fast towards cathode, hit the cathode and make that cathode to eliminate or emit electrons. These electrons, now basically this story understood. These emitted electrons travel, okay, wait, these emitted electrons, okay, now this story understood. See, basically story a plus b whole square, b plus b whole square, amaketan, so whatever. Now, this story you understood. Now, let us come to main story, main plot. Now, emitted electrons. Now, this emitted electrons are coming. Here are again molecules are there. This emitted electron come collide with this molecule. Gas molecule is there. This emitted electron, gas molecule, emitted electrons is coming. Emitted electron is coming and colliding. Once it collide, it may gas molecule to move from lower energy level to upper energy level. It make gas molecules to move here, but gas molecules is unstable here, so gas molecules return downside. While returning it emits some radiations some radiations. Mind blowing. See, it's emitted some radiation, so it becomes light. Now this is dark. Now after emitting radiations, it molecule come down. Now you see one thing, electrons are collided with molecule, electrons are collided with gas molecule, it loses some energy. Now it loses energy, it can't move further, it loses energy and electrons can't move further. At that time this anode says, hey man, come on, I will give some energy to you, I will boost some energy to you. It will give some energy, again it will move up to here. Again it will collide with gas molecule. Again upward. Again downward. Coming, emitting radiation. See, again radiation emitted. Again light area. Again same thing. Again energy loss. Again it is coming. It is producing some kinetic energy. Again traveling. Again hitting the gas molecule. Again higher level. Again lower. Basically, I just want to tell you that in the discharge tube there are gas molecules. When I apply some electric field at low pressure, the gas molecule break down. Positive tries to move towards cathode because it attract, and negative ion moves towards anode. It will attract. Now positive ion go very fast and strike the cathode and make this cathode to emit electrons. That emitted electrons move in the discharge tube, and it will collide with all the gas molecule, and make this gas molecule to go from lower energy level to higher energy level. Now gas molecules is unstable in higher energy level. So it will come again downside. While coming downside, it will emit some radiation. That radiation is responsible for this light area. After emitting radiations, these electrons become very weak, very weak, very weak. So it can't move further. At that time, anode gives some kinetic energy to attack its source, and it got accelerated. Again, moving some forward, it will again collide, again upward, again downward. Again, same process happen. That is why this striation is sorry. This is a clear cut explanation. Yes, 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 yes. Today I learned something. Now, the last case, the boys, the last case. Nothing is there. Only your area. Surface is very bright. Why it is bright means, see in this low pressure, very low pressure. First of all, very low pressure, 0.01, right, 0.01 mmHg, low pressure. At this time, vanish. I said striation vanish, cathode ray vanish, and all over full. It is filled with crocus dark space. All over, it is filled with crocs dark space all over. Now, tell me one thing. If there is nothing, then the electrons emitted here, with which it will collide? There is nothing. So it can't collide with any gas molecule. I said no, no vacuum. Sorry, 0.01 mmHg. It is literally vacuum. So no gas molecules. If no gas molecules, then this emitted electrons to which it will collide? It can't collide. So it will go straight towards these surfaces. And some may can say, sir, why it is not going to positive? Array idiots. This is just observations we did. This is the observations we got. We can't see. Why did it? These are observations we got in experiment. This is not we did. These are the observations we got. Okay now. Now it will travel all over and it will hit these surfaces and make these surfaces bright, bright like your future, bright. Okay now, okay, 0.01 mmg. This is a very important case. All the case very simple, very simple thing, very simple thing. Wait 1 second. uh 8:30 na. Oh, 8:31. Okay, okay. What's the next one? Okay, cathode ray. Okay, okay. Now let's see some cases. Very simple. Strong electric fields between anode and cathode. I just said now we are following some strong electric field between anode and cathode. If this is the case, now this is anode. A strong electric field is between positive and negative. We say okay. Ions hit cathode and release large number of electrons. I said, if this is the cathode place, ions, your positive ions, gas ions, coming, hitting, and emitting large number of electrons from cathode. Okay, the electrons released from the cathode accelerated due to electric field towards anode and acquire high speed. Very simple. See, this is what's telling now. The electrons emitted from the. I just explained. Okay, one more time I'll explain. The electron emitting from this now, it will have high acceleration, move towards positive, positive, and have high kinetic energy. Kinetic energy. That's it. That's it. Now, after moving a small distance, the energetic electrons collide with gas molecule. I said, after moving some distance, it will with gas molecule, collide, collide with gas molecules, collide with gas molecules. Now, one more thing, the gas molecules ionize to excited higher level, I said, and then they are unstable at the higher level, so they jump back to lower level, releasing some radiation. Very simple. I said now, when this molecule collide, this electron collide, these gas molecules move towards higher level, and it is unstable here. So it will come out downside. While coming downside, it emits some radiations, radiations. This is basically five cases, some radiations. Okay now, okay, super. Now up to this, make it clear. We'll meet in next video because it's time for food. Okay, we'll meet in next video. If you like the video, just need to like, subscribe, and do whatever. And there is a link of WhatsApp community in which we post our notes and some exam and all, exam unit test and all. So if you want, you can join them. Okay, thank you, thanks a lot, and have a great day.